All right, algebra students, I'd like you to have your Unit 1 review out in front of you. I'm going to go through the answers and kind of just give you some insights and reminders about each of these concepts before you take your Unit 1 test. As I go through the video, I would like for you to be starring each of your answers, and then you'll turn that corrected review into the sub, who will then be able to give you the test for you to take. So the first thing was classifying each number as rational, irrational, or rational, integer. And I also want to add in here whole. On the test, when you get to this part of the test, please include if it is a whole number or not as well. Remember that a rational number is a number that can be written as a fraction. So if I look at letter A here, we have 56 and 2/10. That is a fraction, so therefore this is a rational number. It is neither an integer nor a whole number because of that fraction that it has at the end. Now there are two types of decimals that are rational. The first type are terminating decimals, decimals that end. The other kind are repeating decimals, ones where you could put the bar notation on the top to show that they go on and on without end. Now if I take a look at this decimal, I know it's not terminating because of the ... However, the ... does not mean that it repeats. It just means it goes on without end. I need to look at the decimal and determine, is there a place that I could put a line over it to show that it repeats? And there is not a place, so therefore it is irrational. On the test, I want you to make sure that you write out the word irrational because then I don't mix it up for I and integer. Okay? The square root of 45 is also an irrational number. Remember that most square roots are irrational unless they are perfect squares. Perfect squares meaning there is a number that goes into them. Now you see that when you multiply by itself, it equals that number under the square root. If I look at 98/13, even if I were to put that into a different form, it's still going to be a mixed number or a fraction only, so it would be a rational number. If I look at the letter E here, the square root is 64. Now 64 is a perfect square because the square root of that would be 8, and this really means like -1 times 8, so that would mean I have -8 plus 10, and that is going to equal 2. 2 is a whole number, and because it's a whole number, I can say it's an integer, and I can also say that it is a rational number. Remember on the test to include whole as well as write out for sure the word irrational. Now let's answer a few questions. All rational numbers are integers. That is false. All integers are rational because you can write all of them as fractions, but not all rational numbers are integers. The square root of a perfect square whole number will always be a rational number. That would be true. It's always going to be a number like 8 or 4 or 2. It'll actually be a whole number, integer and rational. 169 is a perfect square. If you think about the number 169, that is actually 13 times 13. So that is, yes, a perfect square. That would be true. The square root of 72 is between 4 and 5. Well, here we need to think about each number squared. And 4 squared is 16. And 5 squared is 25. 72 does not fall between there, so therefore the square root of 72 is not going to fall between 4 and 5. That would be false. A decimal number that repeats a pattern is an integer. That is false, because remember, integers do not have any decimals or fractions after them. Okay? That is your types of numbers portion. In the properties portion, you will only use each letter once over here. I would take a look and start with kind of what you know. Well, here I'm multiplying, and I'm multiplying by 0, so I'm going to put this as a C. Here I'm multiplying again, and I'm multiplying by 1, so that would be the multiplicative identity property for A. If I look around, I can skip to this one because I see that they took the 3 and they went to each of the terms inside the parentheses, which is the distributive property. Here now I've gotten into subtraction, which remember subtraction is kind of like the inverse operation of adding, so it's going to be one of the adding ones. Am I adding 0? Nope, I'm adding the inverse or the opposite, because subtracting is the same as adding a negative. So this one would be E. Here I'm adding 0. So that's going to be my additive identity, or my B. In this one, if I take a look, I can see that the 4 times 7x switched to 7x times 4. The parentheses remained around the 7x, so it wasn't the grouping that changed, but rather the order, which would mean it's the commutative property. Here I'm multiplying, and if I look, it's the reciprocal of the other, so that would be the multiplicative inverse property. Now I have two to decide. One of them is the associative, and one is not a property at all. Remember, the associative property is about the parentheses switching places. And if I look here, it went from being around the 7 and the x to being around the 4 and the 7. That argument could be said down here as well, but remember that the associative property only works if it's all multiplication or all addition. It does not work with a combination of properties for it. And because if you could simplify this would be 4 plus 7x, whereas this one would be 11x, and those are not equivalent to one another. So this would show me that this would be I, not a property used in the statement. Okay? So again, work through the properties at how you know them, and then from there kind of use process of elimination to complete. Distributive property. If we take a look at that, the first one, when you distribute the 5, would be 5x plus 10. Distributing the 9 would be a 27x, and it's a minus, so it would be minus 90. When they are simplifying ones, make sure you show me both steps. So 4a times 2b would be 8ab. And then it'd be 4 times what I could think of as a negative 6, so it'd be negative 24ac. But we do not distribute to the 10c because that is outside the parentheses. But I can combine the two that have an ac together, so it would be 8ab minus 14ac, because I have a negative 24 and I have a positive 10. That's where I get my negative 14. Now when I have brackets and parentheses with distributing, remember you want to start with the innermost parentheses first, just like you would in order of operations. So I'm going to start with the distributing inside that. So for that reason, I'm going to keep everything else the same. The 2, the x, it's a positive 8. And now I'm going to distribute the 8, and I get 40 minus 8x. Now I can distribute the 2 to each term, and I get 2x plus 80 minus 16x. If I combine my x's, I have a positive 2 and a negative 16, which is negative 14x plus 80. Again, make sure in the distributive property that you show those in-between steps of distributing, and then it's very helpful if it's not a single answer to please box in your answer. Okay. Number 5 is undistributing of the expression. So you want to pull out the biggest number or variable that they have in common, or both. So in this first one, I'll pull out a 2, which is then going to be x plus 5. In B, I'm going to pull out a 4, and so I get 2a plus 9. In letter C, I can see in all those numbers 4 goes into them, but they also all have an x. So I'm going to pull out a 4 and an x. So I take the x away and I'm left with 5, because 4 times 5 is 20. This is a minus, and if I pull a 4 out of the 12, I get 3. And again, I'm going to get rid of the x because I pulled that out. And then the last one, I've got a 4 that came out. I could put a 1, but typically we don't see that, so I'll just put yz. Okay. Sometimes you might only pull out a variable. So in this one, I'm going to pull out a b, because 12, 13, and 14, their greatest common factor is just 1. So if I pull out a b, I have 12a plus 13c minus 14ac. That's your undistributing. Okay. With order of operations, again, make sure you're doing one operation at a time and showing your steps going down vertically. In A, I'm going to start with the start with the multiplication. So it'd be 6 plus 6 minus 1. And 6 plus 6 is 12. 12 minus 1 would be 11. And then I put that answer below and box it in. Inside the parentheses, I'm going to start with the 5 squared. Notice only the 5 is squared because the power is not outside the parentheses. So I'll keep the 2, the 11. I'm going to switch this to a minus 25 plus 9 divided by 3. If I keep going, I'm going to finish up what's in the inside. So I have 2 times a negative 14 plus 9 divided by 3. In this case, on either side, I have multiplication and division. So I could do the multiplication over here because it's just 2 numbers, and the division over here because, again, it's just 2 numbers. And negative 28 plus 3 is negative 25. Number 29. Again, I'm going to start inside the parentheses and probably just clean this 29 times 1 up, because with the multiplicative identity, I know that's just going to be 29 plus 2, and then in parentheses, I'll start with my division. 5 minus 5. 29 plus 2 times 0 is really just 0, so 29 plus 0 is going to give me 29. The letter D, remember that vinculum or that fraction bar is like a grouping symbol. So I'm going to solve what's on top and what's on the bottom before I divide. So up top, if I start with my multiplication that are split apart by the addition, I would have 36 plus 12 all over 24. Well, I need to clean up what's on top. So 48 divided by 24 is a 2. Okay. Again, make sure you're showing your steps nice and clear going down and boxing in your answers. In number 7, it's substitution. So the only extra step here is that we need to rewrite the problem first by substituting in the numbers. When a number is next to a variable, that means to multiply. So I would do 8 times 2 plus 5, which is 16 plus 5, which is 21. Even if 2 variables are next to each other, that also means to multiply. So it'd be 5 times 4 minus 2 times 10, or 20 minus 20, which is 0. Okay, even if it looks easy and stuff, make sure you show your steps and your process. Letter C is z squared, so it's 10 squared plus 3 times 4 plus 4. Or 10 squared plus 3 times 8. 10 squared means 10 times 10, which is 100, plus 24, which is 124. I might want to add that in your test, there are no dividing. So if some of them look like division signs, know that it might just be a foggy copy of the plus. And if I see the operation that you chose or interpreted by, that's kind of what I'll go by when I look at it. All right, 3. Now, in here I have 3, and then it's the power of 2. The power of 2 is just on the end, which is the number 5 squared, plus 2 times 4. Now, if I think of order of operations, powers come before multiplying. So I'm going to keep the 3, and 5 squared is 25, plus 2 times 4. Now, if I simplify up the multiplication, I get 75 plus 8, and 75 plus 8 is 83. Last one says, Julio walks 5 days a week. He walks at a rate for 7 minutes and cools down for 2 minutes. Use a distributive property to write and evaluate an expression that determines the total number of minutes. Julio walks. So 5 days a week he does that. Each day he does 7 minutes plus 2 minutes. And then I would have the 5 days that I want to figure out this total for. Now, they wanted us to use a distributive property, so that means when I solve it, I'm not going to do order of operations and do the parentheses first. I'm actually going to distribute 35 plus 10, and then add them together, and that's what it means to evaluate the expression. I get 45 for it. That would be an example of writing and evaluating a distributive property expression that reflects that scenario that is there. And if I wanted to double check my answer, I could do parentheses first and multiply it by 5, and I'd find I'd get the same answer. Okay. If you can go to the front now and just write maybe how many you got wrong. So if you didn't get any of them wrong, you could put -0, -2. You kind of be the judge. I just want to get an idea of how you did on the review and after watching this video. Hopefully things have been clarified and it was a nice little refresher before the test. You can then take this test and hold it up for the sub to be able to give you the actual test. This was the review, I think is what I meant to say just a moment ago. And do your best, take your time. You can use a pencil, but nothing else. You've got this. I will see you tomorrow. Have a great day.